Lesson 11.4, the Pythagorean. The Pythagorean theorem is a theorem that explains the relationship between the three sides of a right triangle. It's important to remember that it works only for right triangles, and the theorem is a squared plus b squared equals c squared. A and b are the two short sides, and they're called legs. And they will be the two short sides, and they'll always be the sides that touch the right angle. C is the longest side, and it's called the hypotenuse, and that's the side that doesn't touch the right angle. A and B are interchangeable, which means that in this picture, these two short sides, it doesn't matter which one I call A and which one I call B. So I'll say that 4 is A, and B is the side that's missing, and 9 is the long side, that's the hypotenuse. And I can tell because it does not touch the right angle. So putting the values into the Pythagorean theorem, I would now have 4 squared plus b squared equals 9 squared. I'm going to subtract 4 squared from each side, and I'll have to do that on the calculator, or I could do 81 minus 16, but it is not equal to 5 squared. So just be a little careful not to try to take a shortcut that doesn't really work. So I'm doing 4 squared, or 9 squared minus 4 squared is 65. And then I'll need to take the square root of both sides, and b will turn out to be the square root of 65 is 8.1, approximately 8.1. To find the missing hypotenuse, now I would say A is 13, and B is 16, and C is what I'm looking for. So I'll have 13 squared plus 16 squared equals C squared. So on my calculator, I'm going to do 13 squared plus 16 squared, that is 425, equals c squared, and then I'll need to take the square root of 425, so I can get the c by itself, and I'll have 20.6 approximately. The converse of the Pythagorean theorem is just a way of using the Pythagorean theorem backwards. So in this case, we have three numbers, and it's asking us, is that a right triangle or not? So instead of looking for a missing side, we're trying to determine if it's a right triangle. And if it is a right triangle, this relationship should be true. I have to be careful to get the two shorter sides on the same side of the equation as A and B, and then the longer side by itself on the other side. And now I'm just going to check. 7 squared plus 23 squared is 578, and 24 squared is 576. So they're not equal to each other, so this would not be a right triangle. I'll try 15 squared plus 112 squared, putting the two short sides together, and then see if that matches 113 squared. 15 squared plus 112 squared is 12,769, and 113 squared is the same thing, exactly the same. So since they are equal, then yes, that would form, those three sides would form a right triangle. Let's try this one by maybe starting with a picture. A right triangle has one leg that's 4 inches longer than the other leg. So if this is A, this would be A plus 4. And the hypotenuse is the square root of 458. So to put this into an equation, I would have A squared, and then the second leg would be A plus 4, and the whole quantity would be squared, equal to the square root of 458 squared. To simplify this, I would have A squared, and now I'm going to have to FOIL A plus 4 times another A plus 4. That give me A squared plus 8A plus 16. And on the right-hand side, the squaring and the square rooting cancel each other out. So we have a quadratic equation that says 2A squared plus 8A. And then I'm going to take 16 minus 458. That's negative 442 equals 0. I could divide everything in the equation by 2 to see if it gets a little bit easier to work with. And this might be factorable. I'm not sure what 221 is divisible by. So I think maybe I would just do the quadratic formula, and I'll take the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And next on my calculator, I'm taking the square root of 16 minus 4 times 1 times negative 221 is 30. So I have negative 4 plus or minus 30 divided by 2. And negative 4 plus 30 equals 26 divided by 2 is 13. That's one possibility. And negative 4 minus 30 is negative 34 divided by 2 is negative 17, but that's an extraneous solution. And so the answer would be that the legs, one of them would be 13, and the other one, 13 plus 4, would be 17. So they would be 13 and 17. I'm going to try a problem like that again. So we have a right triangle, and one leg is half as long as the other. So let's just say this one's x, then this one would be half of x. And the hypotenuse is 3 times the square root of 5. Putting that in an equation, I would take half of x and square that for one of the legs, square the other x, and then take the 3 times the square root of 5, we'd have to square that. Well, half an x times another half of an x would be 1/4 x squared. And then plus x squared. And 3 times the square root of 5 times 3 times the square root of 5 is 9 times the square root of 25, which is 9 times 5, which is 45. So now I would have 1.25x squared equals 45. And I can solve this one like a fence problem, even though it's a quadratic equation. Since it only has x squareds and it doesn't have x's, I can just solve it as a fence problem. X squared equals 36, so x would be 6. It would really be plus or minus 6, but the negative one wouldn't make any sense. So one of the legs would be equal to 6, and then half of 6 would be 3. The other leg is equal to 3.